Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the use of constants within your applications. We have, in previous videos, covered the concept of variables. Today we're going to be looking at constants and covering the difference between the use of a constant and the use of a variable. First of all, we will declare a local variable as a string. I have declared this local variable as a single letter name. Now, there is nothing intrinsically wrong with declaring your variable as a single letter. PowerBasic will compile it and it will run just fine. However, creating variables with names that do not reflect what is contained within the variable can lead to confusion later on, especially if another programmer has to pick up your code. We can see from this line of code that we are multiplying 42 by 20 by 40, turning that into a string and populating the t variable. We can then output the value of that variable to our log. And we're getting a value of 33,600. From the text on screen, we can assume that this value in t is the total number of hours. We can make the code a little easier to follow by putting each of these values into a variable of its own. But again, as they are single character variable names, it's not particularly obvious what they actually represent. So to make life easier for yourself and for the programmers who follow you, it's best to replace these with more descriptive names. So here we have named our variables staff, departments and hours. And we've put a little comment in against the population of each of these variables to explain what it means. So we can now see that the staff is the number of staff per department. The number of departments is set and the number of hours worked for each person within that department. And we can output that to a log by simply multiplying each of these variables together and populating our string variable. And if we run the application now, it will give us exactly the same value. But the code is now more readable and therefore maintainable. So where do constants come in? Let's assume for the moment that the number of departments is not going to vary. The whole point of putting a value into a variable is that the value held within that variable can change during the run of the application. The whole point of a constant is that the value input to it will not change while the application is running. It's set at compile time. So let's set the number of departments as a constant. At the beginning of our code, we have declared a constant called total departments and made it equal to the value 20. The percentage sign at the beginning of the name indicates to PowerBasic that this is an integer constant. It will accept whole numbers. We can now substitute this for anywhere else in the application where the department value is required. So here you will see that the department variable has been replaced with the total departments constant. When you define a constant at the beginning of your application, when your application is compiled, it will replace any reference to total departments with the value held at the beginning of the application, in this case 20. This ensures that it will not change during the run of the application. If we run the program again now, we will see we're getting exactly the same value. We've also used the format command to put a comma in after thousands. For those of you who are coming to PowerBasic from other applications, you may be used to using a constant keyword. PowerBasic does not have a constant keyword. However, we can emulate it by using macros. As you can see on screen, we've used the macro space constant equals macro. When your application compiles, it will replace the string constant with the word macro. This will mean our declared constant, as in C_long total departments equal to 20, is then a constant. This can be used like any other constant. So if we're replacing our total departments constant with this new VB style constant, we merely have to replace the total departments constant string with the total departments VB style macro. And if we run the application now, we get exactly the same output. So as you can see, you can use the macro keyword to effectively extend the language. So far, we have replaced the total departments with constants. However, the number of hours done per week at the moment has a value of 40. That would be quite easy to replace with a constant, setting its value to 40. However, what if the number of hours done by staff on a weekly basis was not a whole number? In this case, you couldn't use an integer constant because integer constants don't have decimal places. However, for this, the macro again comes to the rescue. If we follow the macro with the name that we wish to use, in this case C for constant, SGL for single, and hours for the name. I tend to keep this naming convention so that regardless of how large your application is, it's easy to see what everything actually is. We can see this one in the code as being a constant, and what it contains is going to be a single, something with a decimal place. And we're making it equal to 375 divided by 10. This, when your application compiles, will slot in the value here into your code, so that this will be calculated at runtime. This allows you to get exactly 37.5. Now that we've set the hours to be 37.5 rather than 40, we should get a reduced number of hours per week, which we do indeed. So this handles numeric constants, either using the standard percentage at the beginning of the name, or using the VB style construct, or using a macro to calculate values which are not whole numbers. So we're going to create another constant, in this case total records, and we're setting its value to be the value 5. If you're performing a for next loop from the value of 1 to 5, we can replace the 5 with our integer constant. If you have a large application, this total records constant may appear many times within your application. And should the value have to change, you merely have to change one line of code. You don't have to hunt through the whole application to find out everywhere the number 5 is used. And we can output the word record followed by the string version of our record number. And we can now run the application to get 5 values out saying record and the number. Like so. As well as numeric constants, we can also have string constants. Say for example we wanted to replace this hard-coded word record with a string constant. And we're going to call it record label. And we can set this up at the beginning of our application. String constants preceded by a single $sign are standard ANSI strings. If you need wide or Unicode strings, you merely have to precede the name with $signs. ANSI string equates each are limited to a maximum of 255 characters. Wide equates are limited to 127 characters. String equates are global through your entire application and can be referenced anywhere. However, string equates must be created outside of subroutines, functions, methods, or properties, ideally at the top of your code for readability. If we run the application now, you will see the word record followed by a space, followed by the record number appears on our log. So we have successfully replaced a hard-coded string with a string constant. Constants which are appropriately named are a powerful method for actually handling large amounts of code. If you have a value that appears many times throughout your application and is not going to be changing during the run of the application, a constant is ideal for this. Hopefully you'll find these techniques useful in your applications, but that's it for today. Thank you for watching.